rule 4b is if you have a non-zero and then a decimal place, any zeros to the right are significant. It's kind of working with rule 4a. So with this one, it says if you have a non-zero, so that's 1, and then you have a decimal, any zeros to the right are significant. So this has a non-zero, it has a decimal, so these zeros all count. The last one's a guess, but this has 3 sig figs. Also, if you had something like 10.00, that's the non-zero, so that counts. There is a decimal, so that means that this 0 counts, this 0 counts, and this 0 counts. So it'll fill in all the zeros when you're going this way. So this has 4 sig figs. All right, so all the zeros will count. This is known, 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 guess. All right, so with this one, as long as you have both a non-zero and a decimal, any zeros in there will count. So this one has 1, 2, 3, 4, 5, 6 sig figs. Okay, let's do the first one. Here we have non-zeros, so they count. There's non-zeros and then a decimal point, which means any zeros to the right all count. So this has 4. These are known, unknown. All right, next one. Non-zero counts, decimal, 0. They all count, so it's 2. Known, guess. All right, here we go. Non-zero, 0, decimal, non-zero. So the zeros in between count. These count because they're not zeros. And then because, again, we had that combo of the non-zero and a decimal, that 0 on the end counts as well. So this has 5. Yes, 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 yes. Unknown. Guess. Okay, and then the last one is a great one for showing us when zeros don't count. So we have that whole in-between 0 here. So this one counts. These count because they're not zeros. This one's in the middle, so it counts. This one at the end does count because it was a non-zero and then a decimal. So that one's good. But this one doesn't count. That rule is still true before, where if it's to the right, doesn't count. Okay, so this has 5 as well. And then these are known. This is our unknown. All right, now, same thing as before. Try putting these in scientific notation. Pause the video, and then put the video back on and see if you got it right. Okay, 12.00. We're going to move the decimal over once. That's going to give us 1.200. And because there's 4 sig figs, remember you have to have 4 sig figs in your coefficient here. Okay, we moved it over one time to the left, which means it's going to be a positive 1. Whenever you're moving to the left, positive, moving to the right, negative. All right, next up, 1.0. Now, this one is a great question for scientific notation. It is not already in scientific notation because remember, scientific notation, you have to have times 10 to something, all right? Now, because we don't want to move it, we want to leave it as 1.0, it would be 1.0 times 10 to the 0 because times 10 to the 0 equals 1. So 1 times 1 still gives you 1, okay? So this would be our answer for this one. And sig figs, it had 2. It has 2 sig figs as well. Next up, we have 10.370. We're going to move this also once to the left. So now we have 1.0370 times 10. It's positive because we went to the left, and we only moved it once, so it's 1 there. And again, make sure you have 5 sig figs in your coefficient. And last but not least, we have 0103.70. This one we're moving 1 2 times. That'll make it 1.0370. Remember, you don't need this 0. It's not significant. Not only do you not need it, you can't put it because it would be wrong because you need 5 for your coefficient. And we moved it over twice because it was to the left, it was positive, And we moved it twice, so we put a 2 there.